Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will help demonstrate how to check your micro-OWL2 optical power meter for proper operation using a laser OWL single mode light source. Patch cables and test equipment should always be checked prior to testing to ensure accurate and reliable test results. This is usually a good idea to do at the beginning of every testing day. In this procedure, we will be using the micro-OWL optical power meter and the laser OWL single mode light source. Now you'll see that there are 3 patch cables and 1 mating sleeve used for this procedure. We have a duplex cable here, a single cable here, and a mating sleeve. Now the reason we have a duplex cable on this side is because these 2 cables will be used to connect the 2 wavelengths in the laser OWL into the link under test. It's easier to handle a duplex cable than 2 simplex cables, so that's why I use a duplex cable here. This 3rd cable will be used to connect the micro-OWL into the link under test when you're actually doing the test. And then this mating sleeve is just used for this procedure to connect everything together, just so that you know that all the cables are working together. One of the main things you need to make sure of is that you have the right connector styles on your patch cables. In this case, we're using SC to SC patch cables. This is assuming that everything in the network is SC. However, if there are different connector styles in the patch panels, then you'll need to make sure that one end of the patch cables can connect into the test equipment, and the other end of the patch cable will plug into the link under test. Now to begin, we simply press the on button on the micro-OWL and the power button on the laser OWL, and you'll see that the 1310 nanometer wavelength is lit by default. Okay, this is the first wavelength that shows up when you power on the laser OWL. On the micro-OWL, you'll see that there are a couple different testing options. In this case, for this procedure, simple meter is the easiest way to check your patch cables. So we will be selecting simple meter by pressing F2. Okay, you see on the screen it says under here. Okay, what this means is that there's no amount of light coming into the detector. There's nothing to measure. This is because the dust cap is on. You see the dust cap here. So if we pull the dust cap off, you'll see that a reading shows up. What this reading is just ambient room light. Obviously there's nothing connected here, so the only thing that could be entering the photodetector is the light from the room. This is normal. Don't worry. This is an acceptable reading for ambient room light. Now, in order to check our patch cables, we first connect in the duplex cable into the light source ports, one for each wavelength here. All right, and then the next thing we do is we plug in our reference cable to the detector port on the micro-OWL. All right, now one thing that we need to do is make sure that all the equipment is set to the same wavelength. The 1310 nanometer is already set on the laser OWL, but you'll see on the micro-OWL it says 850 nanometers. Okay, this is a multi-mode wavelength. This is not what we want for single mode testing. So what we need to do is press the F3 button for wave. We press it until we see 1310 nanometers. Okay, so we see 1310 nanometers. And what we're reading here is minus 10.36 dBm. Okay. We want to make sure we're checking our cables in dBm mode, and we want to make sure that the target reading is met. So our target is minus 10 dBm. Okay, the reading will be a little higher, a little lower, depending on the patch cable. But in this case, we're a little bit lower, but it's acceptable. Really what we want to worry about is make sure that we don't exceed minus 11 dBm. If we go below that level, then there might be more wrong with the patch cable, and it should be discarded, and you should use a different cable. Okay, so we know that 1310 nanometer cable is fine. So we disconnect from the detector and replace the dust cap. It's always a good idea to do so. Then we plug in the 1550 nanometer reference cable. Okay, now you'll notice it went back to under, And the reason for this is that we haven't switched over to 1550. So we simply change the wavelengths to 1550 on both sides. Okay, again, we see about a minus 10.36. Again, this is acceptable. We're not exceeding minus 11 dBm, so we're actually we're good with both of our reference cables for our 1310 and 1550 nanometers. But now we need to check this third cable. The easiest way to do this is to temporarily zero out this 1550 nanometer wavelength and then insert this cable in between the detector and the reference cable via this mating sleeve here. Okay, so to zero out this wavelength, we simply either press the F2 key where it says 0 here, or we can press the 0 button. So we'll press F2. We'll confirm that we're setting a 1550 reference, and we'll see that we now read around 0 dB. Okay, remember we're in dB mode now since we've zeroed out. dB is loss mode. Now what we do is we insert this cable in between the detector and the reference cable. So we have to disconnect from the power meter. We plug in the mating sleeve, plug the test cable into the other side of the mating sleeve, and finally we plug the end of the test cable back into the micro owl. Okay. We see a reading of minus 0.07 dB. Okay, what this means is that this cable and this mating sleeve are adding about roughly 1/10 of a dB of loss into the link. Okay, this is actually very good. Usually you're going to have a couple tenths of dB of loss depending on the quality of your mating sleeve here. So because we're only losing 1/10 of a dB, we're very good. Now the reason this is important to check the patch cable this way is that this cable right here will not be part of your reference. You won't be zeroing out during this procedure. This cable will actually be adding into your loss measurement when you're taking taking the loss measurement. So it's best to check this cable first. And again, we're below minus 0.1 dB of loss. In fact, really, if you want to make sure that the cable's good, just make it so that it's a little less than 0.4, 0.5 dB. That's kind of a cutoff for this procedure. Anything below that, you may want to either consider replacing the cable, or maybe the adapter here or mating sleeve is not very good. So anyway, we've checked our patch cables. They're all good, and now we can start our measurements.
If the power level falls below the acceptable power level range, debris such as dust, dirt, or finger oil may have collected on the connector end face or in the equipment's optical ports. Thoroughly clean and inspect all connector end faces and equipment's optical ports according to industry standard cleaning procedures. Several cleaning cycles may be required. Keeping connectors and optical ports clean at all times helps to keep test equipment in good working order and proper calibration, ensuring accurate and reliable test results. When not in use, dust caps should be kept on fiber connectors and optical ports to keep debris from collecting on the surfaces of the connectors and ports. During testing, it is highly recommended to clean and inspect both connectors and optical ports every time a connection is made. Failure to properly maintain your test equipment could needlessly result in costly repairs. For example, over time, repeated connector insertions into a dirty optical port could grind the debris into the optics in an equipment port. This type of damage is permanent and cannot be repaired in the field. If the problem still exists after thorough cleaning and inspection, the patch cable may need to be replaced. Patch cables are typically rated for a few hundred connector insertions, but can prematurely wear out or become damaged if they are not properly handled and maintained. If the power level is still too low, even after patch cable replacement, contact OWL technical support for assistance. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.